Hi, my name is Morgan Edwards, and today I will be talking about the chemistry of pearls for our final talk project. Did you know that pearls are actually living rocks? Pearls are produced by living organisms and composed of true minerals. They're made mostly of aragonite, but clams use calcium carbonate to create pearls. There are two types of pearls, natural and cultured pearls. Natural pearls are produced in nature and formed when an irritant like a shell is lodged in an oyster. Cultured pearls are made by scientists implanting a nucleus into the oyster, which acts as an irritant. The pearls are formed with nacre, also known as mother of pearl, and are made with alternating layers of calcium carbonate and nacre, and protein, which allows pearls to refract light. The physical properties of pearls consist of size, shape, hardness, color, and luster. The chemical properties of pearls are calcium carbonate, nacre, and trace elements. They also contain conchiolin, which holds the chemical structure together.
Hi everyone, my name is Megan and I'm here to talk to you about the ionic bonding and compound formation of pearls. Pearls are mainly composed of the mineral calcium carbonate, which forms through ionic bonding between positively and negatively charged ions. Um, Calcium carbonate is a commonly found substance in rocks, shells, and pearls, things you find at the beach. And the formula just represents one calcium atom, one carbon atom, and three oxygen atoms, resulting in CaCO3. In pearls, calcium ions bond with carbonate ions to create a solid mineral structure, which is what gives all of those materials that you find at the beach that hardness and that strong, hard feeling in your hands when you feel it. Um, in the formation of ions, calcium is a metal and it tends to lose two electrons to achieve a stable electron configuration within the formula of the bond, and it produces a calcium ion with a +2 charge. And the carbonate ion is a polyatomic ion formed from carbon and oxygen atoms that carry a -2 charge. So they bond together positively and negatively to form a more stable and strong ionic bond. These ions exist in seawater and are typically used by many mollusks and mussels when forming pearls over time. Ionic bonding, like we said before, is because of the positive and negative ionic bonding between the calcium ion and the carbonate ion. And the attraction of that actually forms a lattice-like structure within like pearls or these shells or rocks that give it its durability, its hardness, and its ability to last a long time, and a crystalline internal structure if you were to break one open and see the inside. As you can see in the formula, that is what it looks like when that lattice structure is formed from those calcium carbonate ions.
Hi, my name is Kylie Copeland, and I will be going over the precipitation reaction in pearl formation. Seawater contains many dissolved ions. These ions come from rocks, rivers, and natural chemical processes. For pearl formation, the important ones are calcium ions and carbonate ions. These ions float freely in seawater until conditions allow them to combine. A precipitation reaction happens when two dissolved ions combine to form a solid that no longer dissolves in water. Inside an oyster, calcium ions enter the oyster from seawater. Carbonate ions are produced inside the oyster, and these ions combine to form solid calcium carbonate. This solid calcium carbonate forms tiny crystals that layer together to create a pearl. So how exactly does a formation of solid calcium carbonate occur? Well, when an irritant enters the oyster, like sand or a parasite, the oyster protects itself by releasing layers of nacre, also known as mother of pearl, which is the substance that contains crystals of calcium carbonate. These crystals build up layer by layer, resulting in a pearl. In order for this precipitation reaction to happen, There must be sufficient ion concentration, meaning there must be enough calcium and carbonate ions in the solution. The pH level is important as well. Higher pH leads to more carbonate ions, resulting in easier calcium carbonate precipitation. Another factor is temperature. Warmer water can increase precipitation, which is why we see more pearls grown in tropical climates.
My name is Alexandra Castro, and I will be going over acid-base reactions in pearl distribution. In water, carbonate ions can interact with hydrogen ions. Because carbonate is basic, it can neutralize acids by accepting hydrogen ions. This means environments that are more acidic can start to break down materials made of calcium carbonate, including pearls. A key chemical reaction that demonstrates this is the reaction between calcium carbonate and an acid. When CaCO3 reacts with an acid like hydrochloric acid, the products are calcium salt, water, and carbon dioxide gas. You may notice the production of carbon dioxide gas as bubbling. This is the same reaction that occurs when vinegar reacts with chalk or seashells. Because pearls contain calcium carbonate, they are also vulnerable to similar acid reactions. This leads to the importance of pH in pearl stability. Pearls are most stable in environments that are neutral or slightly basic, like seawater. The chemistry is also relevant to pearl distribution in nature. Pearls are commonly produced in marine environments where the pH remains stable. In areas where water becomes more acidic, like regions affected by ocean acidification, calcium carbonate structures can become weaker or dissolve over time. The big idea of pearls comes down to how much of a role chemistry plays in the structure and durability. Both factors are huge indications of the value and how pearls were made. The structure of pearls can impact how shimmery and the color of the pearl, while the durability can indicate how vulnerable the pearl is to acids. Thank you for listening.